You guys want to know the worst thing about living your life to the fullest? No. Okay. Today we have to talk about the difference between an isosceles and an equilateral triangle. So, yeah, we're not going to talk anything about those. Scalene triangles, we'll talk a little bit about them. Does anyone know what a scalene triangle is? All the sides are different, right? That's the most you're going to hear me talk about scalene. You will hear us talk a lot about equilateral and a lot about isosceles triangles because these are the two most applicable triangles you're actually going to see. So here we have an isosceles triangle. What can you tell me about an isosceles triangle?
Sides are the same.
Two sides and angles are congruent. So isosceles triangles, is it blurry? What the heck? What's this? Alright, so isosceles triangles on two sides and angles are congruent. Now, here's an interesting question for you. First things first, let me get to this and then we'll ask you the interesting question. Two sides and angles are congruent. What it means is if these two sides are congruent, then the angles opposite those sides are also congruent. Right? So no matter what, if the two sides are congruent, then the angles opposite those sides are also congruent. But it makes sense, right? If an angle makes a side, if that angle's this, it's going to have the same side measure if it has the same angle, right? The angle over here. So if this thing was to get bigger, this thing would have to get bigger to keep the same side, so it would stay an isosceles triangle. Now the question I want to pose to you is this. An equilateral triangle is what? So equilateral triangle are all sides are congruent and all angles. All sides and angles are congruent. That's an equilateral triangle. So inside of an equilateral triangle, what's the measure of each angle? No matter what. Okay, no matter what, equilateral triangles have to have angles that are 60 degrees. Now there's no other option, right? Because they have to be the same and they have to add up to be 180. So they have to be 60 degrees. So an equilateral triangle's angles are always 60 degrees. Alright, any questions so far? Okay, let me pitch an idea to you. Isosceles triangles say two sides and angles are congruent. Is an equilateral triangle an isosceles triangle? Yeah, it is, right? Because it at least has two sides that are congruent. Right? So an equilateral triangle is in fact an isosceles triangle also. Because isosceles is actually two or more. We just don't ever talk about it. Yeah. Okay? So, now an equilateral triangle is an isosceles because it has at least two congruent sides. So, isosceles, two congruent sides. Now look at an isosceles. This is where most people get mistaken when it comes to isosceles triangles. These are the angles that are congruent. The angles opposite the sides that are congruent are the angles that are congruent. Don't get that confused. Oftentimes I see too many times where students will see that they'll give you this one and they'll say, what's this? So for example, here's an example of one. If we have a triangle and we're told, I would write down a couple of these. If we're told this is 100 degrees and it wanted to know what we'll just call this x. Too often I've seen students do this and make this mistake. They think, well, that's 100, that's 100. First off, that's impossible, right? Because that's 200. But you get so ingrained into your mind that if two sides are congruent, the two angles are congruent. It is 40. Jordan, how did you get it? Tell me how. Okay, so we know two things. Now listen, if this is 100, we know that those two angles are equal because it's an isosceles triangle, so they have to be the same. So what you do is just go 180 minus 100 and get 80. And if those are the same, we can just divide it by 2, and we know each one of these angles right here would have to be 40 degrees. Pretty easy, right? Okay, try this one out on your own real quick. Let me create one here for you, or you have to find it. You will, because those are the same, right? So now listen, what about if they give you this angle? Could you find all the other angles? Really easy. If this is 30, this is 30, this is 120, right? They have to be 180.
What if it's like 101 on the top?
That's then you'll have 0.5. So you'll have whatever it is, 38.5-ish, 39.5.
So you can have it.
Yeah, for sure. Yeah, you will see actually some decimals today. I think we start seeing decimals as angles, which is okay. What about if so here, do this one on your own. If I'm told here's my angle, and all it's going to say to me is this is 9, that's 9, this is 26. I want you to find that angle right there.
Oh, almost there. Oh, I know.
Hold on. Tell me how. Tyson?
The other side is 26.
Awesome.
26 plus 26 is 52.
Okay?
And then 180 minus 52. 28.
Good. Which means that's 128. Any questions on that right now? Okay. Questions? All right, let's get a little bit tougher here. If I have a great big triangle here, so all these theorems, just those two things, I didn't mean to draw this extended side, just ignore that. If I'm told that this is 90, and I have another one that's coming down like this, and I'm told that this is equal to that, and I'm told that this is 48, and I need to find that. Okay, so everyone look at this picture with me real quick. Draw this one actually down so you guys can see it. So you have another example of this. Okay. All right. So there's two ways to do this. Well, I think there is only one way that I think that you should do it. There is a couple ways, but I would do it this way. What angle would you guys find first? What does that do? Okay, that can help us out, right? So let's do it real quick. This is one way to do it. This isn't the way I'd do it. Okay, so if we find this top one, what is it? Is it 40, 32? Okay, 32, but can that...
It's not 32.
Is that not 32?
I don't think so. It's 32.
No, it's not. It's 42.
Ah, yes! Oh, yeah.
Okay.
Did you see that?
What?
Logan's like this, and they made the same high five each other.
Yeah, it like made the same sound as a high five when you slapped my face.
He was like this.
Okay, but... Yeah, so listen, this doesn't help us out at all. Look at this. What does that do for us? That helps us if you wanted to help find this entire thing, right? Now watch what I would do. I would actually go 180 minus 48, which gives us 132, right?
Yes, sir.
Okay, now look at this real quick. There is another way I would have done this, and it's going to shock everyone. Now, how do I know that's 132? Because this plus this is 180 because those are a linear pair, right? And then you could just subtract that from 180, divide by 2, and we know that each one of these would be 24. Okay, tell me another way you could solve that. Think about the theorems and the things we've already talked about. Ethan. Boom! Extended angle theorem. If this is 48 this angles opposite that equal that, and we know based upon isosceles triangles that those have to be the same, so you get it. See that?
Wait, I didn't get it.
It's okay, listen, let's look at it again here.
Like 48.
Stop talking. Here we go. This is important. Oh my goodness, I did it again. Here we go. If I'm told that this is 48 and I'm told that this is an isosceles triangle, I know one thing right now. I know that angle equals that angle. Well, that's an extended angle of this triangle. So if this is 48, that means that this and this have to add up to be 48, and they have to be the same because it's an isosceles triangle, so it could be 24 and 24.
What's that called?
The extended angle theorem, extended angle.
Fantastic.
Hey, so good job, Ethan. That's actually the way I'd have done it. Now, remember when I told you when we learned this, I said this little thing right here is going to save you time. Now, look, we're only talking about one step farther, honestly. This, you could still do it. We did it that other way, too. You did it to here. Okay, you got to here, and then you had to. That's fine, too. Either way works. But one way is just a little bit easier than the other way.
I think that's not right. You forgot the word square. It's not.
Oh, yeah.
It's 90.
Well, we don't have to know that's 90. Why does that help us get the
I
answer?
don't know. It was
Extended
bothering
angle
me. It was
theorem.
bothering me because I wanted the little square in the corner.
Okay, now listen, alright. This is going to get a little bit weird right now. Everyone ready? Alex does some problems, and I'm going to copy down a couple directly off your homework here. And I want them down inside your journal so you guys can kind of see them.
Look at it, right?
Okay. First initial thing is, what's everyone thinking x is? It's not 72.
What is it?
Okay, good. Well, if you looked at the picture, it's not going to be 72. We have two sets of isosceles triangles here. We have one set right here, and we have another set down here. Now, this triangle, those two sides are congruent. This triangle, those two sides are congruent. I know they touch. We don't trust the picture right now. Okay, we're going to find out everything that we can to be able to get to x. Okay, so we know that this has to be 72 because this is an isosceles triangle. Okay, how can we find this down here? This angle right there. Okay, no, we can go. Okay, which is what? 36 degrees. Okay, now what does that do for us?
Absolutely nothing.
90 minus 36, which is, what's this one?
54.
Okay, now everyone look at this. This is where a lot of people, when I've seen these problems in years past, get confused. Is they automatically assume, because this is 72 and all these sides are congruent, that that's 72. It's not.
So the one in the corner is going to be.
These right here are different triangles. Even though they're part of the same figure, they are different triangles. So if this is 54, we can go 180 minus 54, and we get 126.
Divided by 2.
So this is 63, and that's 63. Does everyone see what you had to do there? Now look, we had to find one. Is that not right? Two. We had to find 1, 2, 3. 3 different parts to be able to get to our solution. Daxton, you got to quit talking. Oh, Jordan, you got to quit talking. See that? How we had to find 3? We had to find 3 different parts to that problem in order to get to the solution they wanted us to get to. Very rarely are they going to give you a problem where you can see the answer outright. Okay, we're going to do another one. Here we go.
Wait, I'm going to see it. It's kind of hard.
Okay, if we have another one, here I'll try to fit it in here. This one's directly off your homework too. I'd encourage you to write down all these because I'm pulling these things directly off your homework.
Our homework is always different.
It is, but you'll have similar ones. That should be more of an isosceles triangle. We don't trust the picture anyway, so it doesn't matter. All right. Okay. Max, tell me one of the angles.
Can you see it now?
Which one? So if we know this is 34, do we know anything else?
Yeah, the one up next to X is 34.
Okay. But that doesn't help us find X yet, right?
Because you gotta add those things.
Okay, so we got to add these together and subtract them from 180.
It is 110.
Is it 110? No, it's not 110.
No, it's not.
112.
Yeah.
So we know that's 112. We also know that's going to be 68 because this is a linear pair. Now look, now we're done with that triangle. If you ever finish off a triangle, now look, now we're on to this one. Does everyone see that? Because now we're on to a different kind of a triangle here. Now this is 68 and this is another isosceles, so that has to be 68. Right? So that's, yeah, 116. No, 136. 136, which is 44, is going to be X.
Wait, how do you know that's a linear pair?
Because it's on the same line.
Same line, yep.
Is it?
A line equals 180 degrees.
This isn't, that's not a straight line.
The other triangle.
Up here, that's not a straight line.
Yeah, but you said you don't trust pictures.
Trust your math. We don't trust the picture.
Yeah, but if
But
it's
you
a
just
straight
said
line in the.
If it was a straight, well, look, well, we know that this is because you can see it here. Trust that. If it's there, but if it's bent like this, don't do it. But if it's a straight line, they're not going to screw up a straight line. The things they're going to screw up are like the shapes of triangles and stuff like that. Now, Sam told us another way we could have done it. Sam, what's another way? Okay, so look right here. That angle equals that angle plus that angle. Well, we know that's 68. 112 minus 68 is 44. So there's another way you could have got it right off the bat too. But anyways, those are just some examples you're going to see today. The reason why I like showing those, and I have to get to, I think there's one more thing we got to get to today. And this is equations. So those are the kind of things you're going to see today. And the reason why I like showing those problems directly off your homework is because it teaches you that you have to find things they don't ask you to find in order to find things they ask you to find. And that's why I like doing that. So let's get to the last thing here. If we have an isosceles triangle, and I'm only going to do one of these because I think this isn't going to be that hard for you guys, maybe. But maybe not. Okay, if I'm told that this angle right here is 3x plus 30, and this angle here is 2x plus 6. Okay, see ya. And this is angle A, B, and C. And they tell me they want to find angle A, angle B, and angle C. Perfect. Allie, why would we set them equal to each other? Daxton. Yep, because it's an isosceles triangle, we can set them equal to each other. So now we're to there. So now what do we do? That should be, timeout, that should be 36. So we subtract 2x to both sides, we get x plus 30 equals 36. Now what? So x equals 6. Okay. So now we're going to plug it back in. Now, would we need to plug it into both of these? Daxton, come set up here. Daxton, underneath the smart board. Hurry. So look, we don't need to find both, right? Because if we find this one, which we know if we plug 6 into this, we get 48. If that's 48, then this one also has to be 48 because it's isosceles triangle. We actually don't even need to plug it into this one, right?
Yeah.
Okay, Daxton, how do we find angle B without looking?
You.
Add them up.
I have to look.
Not too bad guess.
You add them up
Then
and find it.
subtract from.
Subtract it from 180.
Good. So we add them up, we get 96, subtract from 180, we get 84 degrees of B angle B. Okay, all we had to do is plug 6 back into here, just like this. Well, that's too bad, because your homework's coming. Okay,
I actually think so.
3 times 6. No, I would use 9. That's it. All we did was she solved it, got 6. You can plug it back into either angle and get 48. Okay.